get started. First of all, I'd like to thank Insight and the rest of the family and companies to invite me to present. I want to warn you up front, I'm not a professional presenter. I don't do this all the time, so you're welcome to throw fruits and vegetables at me, but please no splatters. So, okay, thanks very much. I wanted to be able to talk today a bit about our evolution and history of the family of companies that make up the Pulse-Puller family. It's really kind of an interesting and dynamic evolution. First of all, I wanted to introduce myself and my background, whom I worked for, and then go into some of the evolutionary steps that we went through, as well as talking about some of the applications that we've applied in the industry, and some of them are pretty massive and pretty interesting. So, who am I? I'm the Director of Product Development for Wynright. I've been involved in doing product development now for about the last 10 years, and I've got a lifetime of material handling. I don't know, it's like, when you get into the material handling industry, it seems like in order to get out of it, you got to have a blood transfusion. And the people that seem to get into it just don't get out of it. I'm kind of that same kind of guy. I've been in it all my life. I started out with automotion. I actually started with the son of Hank Haymanowski, one of the founding fathers of automotion. And summers and weekends as a kid, grew up, working in a shop, doing everything. It's like assortments and bolts, to assemblies, to fabrication, run the machine shop, all kinds of things. And then after some, 20 years with automotion, I went to WEI, and I worked for Mike Scheck as a VP of Engineering and Systems Engineering. It was really kind of an interesting thing. I had no idea that ultimately Mike Scheck would end up owning all of Wynright, which it became Wynright in, I forget what year it was, but essentially it was a collection of companies that got brought into one name under the Wynright banner. And now, as of October of 2013, we were purchased by Daifuku, which is a completely different context. So I've had, as much as I've tried to not be in one place, it seems like no matter what I did, I was still in one place, under one company. So the context change is really kind of interesting. I started out where there was only 10 employees, and now, 4 years later, I'm in a company that has 7,000 employees. Completely different. Okay, as I said, I was doing product development for the last decade, mostly retail distribution, conveyor products, and the continual challenges. It's like the market is amazing in how creative it is in terms of what they think they need and what they think they want. And so it's this continual, discovery of what does the market really want, how do you respond to it. Okay, who's Wynright? Currently, we still have the Wynright name, even though we've been picked up by Daifuku, but it was a private entity under the Mike Scheck family, and there was 15 to 18 sub-companies in that family. It's like a small conglomerate, and it was sold to Daifuku in October of 2013. It's currently comprised of multiple sales and system engineering locations. We've got conveyor manufacturing, heavy steel manufacturing, mechanical, electrical, software engineering, lots of locations across the country. Installation groups, pick-to-light, voice picking, robotics out of Arlington, Texas, and all kinds of client care support staffing. Okay, we've got 2 sales channels. Primarily, it's internal. It's the internal companies or integration companies. They primarily handle larger projects, mega projects, things that are very difficult for a small distributor to handle. Then we have a distributor channel as well. We've got something like 75 distributors that work with us, and probably the top 10 do most of the heavy lifting. The projects that that can range anywhere from 200,000 to 5 or 8 million, something like that. Okay. Primarily retail distribution with some manufacturing. The ratio is probably 95% retail distribution, and we only get into maybe 5% of manufacturing environments. Now that's just for the Wynright functionality. Get into Daifuku, it's a little different story. Who's Daifuku? It's a global company. You know, my exposure to these guys has been, you know, roughly 2 years, and I still don't understand the size and the scope and the depth of what they offer. It's an absolutely massive company. Really good engineers, really smart products, an interesting array of products, and they've got a lot of different locations, Tokyo, Shiga, Osaka, Kamaki, and then a network of companies that are also part of that. So they're in over 20 countries and regions. They've really got a strong global presence at the company. As far as business segments, manufacturing and distribution, they call it FADA for some reason, clean room production line systems, automobile production line, airport baggage, lifestyle products, electronics. Just to give you an idea of what I'm talking about in terms of size and depth. For electronics, in just that one segment, there's a company that we have called Contact DTX. There's over 500 electronics engineers that are part of the company. And the catalog of operates, the catalog is like 1.5 inches thick of everything from, you know, HMIs to PCs and micro PCs and just cables and everything. It's a tremendous offering. Okay, Shiga works. I spent a couple of visits at Shiga. It's a 238-acre campus, and effectively they've got 11 manufacturing buildings that are just absolutely massive. Each and every one of them, you know, builds a different product in a different way. It's a fascinating place. They've got the second largest solar array in Japan. It covers the area of about a 9-hole golf course. You know, this is a fascinating company with a fair amount of momentum. Okay, our history with motor-driven roller. This is more to the subject. You know, 10 years ago, Mike Scheck and the family says, okay, you know, let's go to ProMat and let's walk around. So in 2005, we're walking around ProMat, and he says, okay, now hunt down what you think is innovative. And we're saying to ourselves, okay, well, what is he really after, right? I mean, it's like an open question. He goes, come on back tonight, and we'll talk it over, and let's find out, you know, who's on the ball and who isn't. They come back that evening, you know, at dinners, and everybody's thinking, okay, this is what's innovative, this is what's progressive. And for some reason I said, well, MDR's it. There's a presence here, there's things going on. So I'm not sure if I raised my hand or if everybody stepped backwards a yard. You know, it's like, okay, well, Don, good answer. You know, I want to do an MDR development, and that development is going to involve all these figures that we can think of that the market might need. And oh, by the way, I want it done in 6 months. Like, okay, and then like every month after that was like, okay, are you done yet? Are you done yet? Are you done yet? Are you done yet? And it's like, okay, in 6 months we completed a total of 20 figures to supply to the market, not just, you know, a simple accumulation in a curve, but the whole idea of providing the tools to be able to create a system, a complete system, you know, with diverts and merges and inclines and declines and gates and with all kinds of variability. Well, in 6 months we got 20 of those figures complete, and there were 2 others that took longer because they were complicated. But what a great evolution. So we started out with Ito. And why did we start with Ito? We started with Ito because we didn't know anything. And they seemed to be the preeminent, you know, product at the show. So let's start there and let's learn something, right? Not a bad idea. So we go down the line with Ito, and actually the product's pretty good. But then Mike says, hey, the margin's not there. And then Merle Davis, the president of Automotion, goes, hey, we're getting boned on deliveries. And it's like, okay, now we got to do something else, which is all very interesting. Well, what do you mean something else? Well, we need to control our fate better. Let's do something else. What is that something else? Okay, and then became the goose chase. Okay, in order to be able to manage our calendar and build margin, we thought, smart people we are, we're just going to go do it ourselves, right? How hard can that be? How hard can it be? Because you know how hard it is. Yeah. So we had a couple of bad actors in the equation, some people that we listened to that maybe we shouldn't have. We go off to Japan, because Japan is like the home of MDR, right? And we start visiting places, motor places, and gearbox places, and talking to people about how to do this. And we go round and round and round while we're still selling Ito, only to find out that, wow, now we really don't know what we're doing. You know, I don't mind admitting it that we're down a path that doesn't make any sense. So, I don't know, 6 months later, we throw the pages up in the air and say, okay, now what do we do? Lo and behold, we run across a young fellow that comes into our development office in Grand Rapids, and he says, hey, I know some guys, you know, I think Tim Barnes knows who they are.
Yeah.
And Kazuya, and so we started the Insight pulse roller adventure. And really an interesting adventure. You know, so now we're talking to people that have, it was almost like, it was like setting up a string quartet where you wanted to have the right players playing the right music on the right instruments. And so Kiowa brings, you know, a great guitar player, and Jimmy brings, you know, a great bass guitar player, and Tim brings a great violinist, and, you know, then we bring effectively the ability to test and profile the product. So as we're going forward in the discovery of all of this, we say to ourselves, well, this could be pretty good. But how does it get better? How do we build that margin? How do we control that fate? So I talk about a couple other things here as far as like card game with friends. This became a loose partnership. And the partnership was very interesting because what we wanted to be able to do is actually build rollers on our property. In other words, we want to be able to buy components from Kiowa as far as the motor gearbox, the intermediate plate. I'll design the bearings and the tube stuff, and then we'll create a process in-house by which we're going to do things. So we figured we build it, we will hum. Or NFB WWM. Well, what the heck does that mean? And what that really means is it's a quote from Sarah Connor in the first Terminator movie, where she says, there's no fate but what we make. We figured if we can at least control how we build things, we can control margin building, and calendar. So it makes perfect sense. So now we're on a path that makes some sense, and we got some partners that make some sense. So we can go on to do test components, assemblies, and we give our feedback to Kiowa, feedback to Jimmy, you know, as we're training folks, feedback to Insight, what makes sense, what doesn't make sense. You know, we put things in our own test facility. You know, we run a giant MDR loop to determine if all these figures in fact work with your products, our products. We do a roller lab by which we test each and every product that comes through, you know, for capability. And then after we build it and we certify it, then it goes out to the shop assembly. And in the shop, they essentially set it up and test it as well. So from the QC side, everything's looking pretty good. Okay, you know, this is so important, at least for us anyway, is that in order to control variability, we're on the subject, we're white hot focused on everything we build and how we do it. And at the same time, we're in that continual improvement loop, you know, with everybody that's giving us feedback. That customer says, hey, you know, this doesn't work quite right. You And we go, hey, Insight, this firmware's not quite right. We go, hey, Jimmy, what's this? But all you guys responded back to us, and we continually improved the product and moved the ball forward. It was very interesting. Very curious about training and controls mentality. In the internal groups within Wynright, we got a bunch of different controls engineers. And I'm not sure I understand this, but it seems like controls engineers want to be able to direct and command every electron. You know, it's like, what is it with these guys? And I know, Pat Namke, you got to defend yourself.
Something wrong with this mentality?
I don't know, you got to explain it to me, because I don't ever understand it. But like, you know, we had some folks that would come to us and say, hey, we like your MDR, but we want DeviceNet. It's like, okay, you realize that, you know, DeviceNet 1799 card doesn't have a commutation card. Yeah, we get that. You know that when you add this onto that the cost per zone is, you know, out the window. You know, by the way, you got to tell every move what to do and how to do it. And we're thinking, well, why can't you just trust the card? You know, trust the card. And it's very interesting through the evolution of what we've done from, you know, 8 years ago to where we are today. You know, Jimmy, you're fantastic at pulling up all the improvements to the firmware and then saying, okay, I've got a new improvement. I've got a new improvement. I've got a new improvement. There's another improvement. I'm thinking, wow, this is really cool. The controls engineers are thinking, this firmware's not stable. I got an improvement every week. Wait a minute, time out. This isn't good, right? So we said, okay, let's stop. I said, stop. I said, we're not going to publish any more improvements. We said, okay, firmware 4.14, we're going to call it 50.1, and we're never going to change it unless there's a reason to. And we said, we'll back off of that. We said, okay, every year we'll do an evaluation. And if the changes that you've made in that 1 year period of time, we'll go ahead and evaluate each and every change and see if it makes a difference for us. And then we'll train the people from our controls groups to let them know what that was about. Before, they just get the change and go, oh, firmware's not stable. Well, time out, it's sure it's stable. You just don't understand it. You know, so fascinating sequence there. Okay. So, 22 standard figures, complete offering. And initially, you know, we did a lot of DeviceNet work. We said, this is crazy, we can't make any money with that. Did a lot of ETO work, which was okay, but we were still getting boned on margin and deliveries. Not to knock them, I thought they had a good product, but we got hurt sometimes. And we went to the CRSC card. We can't open. Did a few projects there. Very interesting product line. Maybe it worked well for FSS, but our systems engineers, mechanical engineers, would take the figures and they would say, well, this is close, but I want to do something different. Well, wait a minute, it's not a predefined figure. So they design a system and they have, you know, a system that had new figures in it that weren't predefined by Jimmy's firmware. It's like, well, you just made something up, you just dreamed something up, Mr. Systems Controls guy, you know, and it doesn't work. Well, what do you mean it doesn't work? We haven't defined it yet. So we did, I think, 5 or 6 major systems, you know, with the CRSC, and we fought to make them successful. They all did, they all work, but I'm glad the ERSC card came along. Because now you've got 2-zone configuration, Ethernet based, you can configure what you want to do, life is getting easier. It's a good evolution. So, I wanted to talk about some of the, this is kind of fuzzy, but we have how to specify pages for each figure that we have. For example, you know, here we've got a belted gate, and there's literally unbelievable number of permutations that you can order based upon just 22 figures. You know, you can have 2 different card types, you can have different widths, and it's different zone lengths, different assembly hands. Roller centers can be different, can be belted or not belted. You know, control voltage can be different. Nominal speed, different chart. You want to pick different colors. You know, plethora of colors. You like purple? We got purple. Okay, and then some things that are not so standard we even developed, which is like a typical H configuration. You know, we've got a right angle transfer on the inside, and then coming in and out, depending on what you're doing in a big module. You know, so we went through all the sophistication of all of that. Okay, most popular applications, standard accumulation. We do lots of standard accumulation. 3-inch on center, 24-inch zone, 36-inch zone, pretty typical stuff. Again, with all the possibilities here of what you could possibly do, left hand, right hand, roller centers, the whole bit. So in other words, we're really trying to address, you know, the bulk of the marketplace and having offerings that make sense to a lot of folks. This typically very strong, sellable, repeatable. Another popular offering, right angle transfer. Here we've got an example where we've got a reject lane. We've got a right angle transfer that's just, you know, you don't read the barcode, you just kick it off to a hospital. No big deal, but this is a very typical figure for us. Widely used. We're up for a redesign. You can get this in either a pneumatic lift or an electric lift, but we've got some other ideas on how to get more throughput. So it's a project that we've got going forward here to redesign this unit to get more throughput out of it. Well, this is kind of interesting. You'll note here that on these belted MDR zones, they're coming to a workstation, perfectly spaced. And this is for a major shoe retailer. And effectively what they're doing is these full cases come to this workstation. A person is standing there and opening up the case, and if the order says, okay, I need 6 from this box or 4 from this box, they put it on a lane on this side, and that lane is also belted MDR going into a tilt tray sorter induct. And then if there's still some left in the box, they take and fold the flaps back and they put this yellow holder on the top of it, and they send it down the right-hand side, and then it gets re-indexed back to an ASRS system. You know, so we call the residuals, the ones that aren't picked, going back to the ASRS. This is real typical. You know, let's say, for example, all of the products came out of this case, and I've got an empty, then there's a trash conveyor in the back, you know, throw the empty box into the takeaway. Here we've got another example of the same thing, but with longer belted zones. This was to another shoe retailer, distributor, and they were doing manual puts to a tilt tray sorter. So again, product would come down these lanes, you know, completely separated. You know, in this case, they were putting all of the cases on because they're picking full groups. Now, this is an interesting picture. Here we have NDR down the entire line feeding 21 crane aisles. So we've got, you know, 2 belted zones and then a right angle transfer feeding into the crane. This is 21 lanes on top for inbound and then 21 lanes outbound underneath it. And this is all MDR intensive. Everything going into this area and coming out of the area, it's all MDR. This is another curious one. Another shoe retailer, different customer. We're using MDR in our multi-belt sorter for a 90-degree right angle transfer. So what you see here are 3 multi-belt sorters that have 61 diverts in each. So each divert is powered by 3 synergy rollers and using 24 cards running in sync. So effectively, we're running trains of cases to a lane, and each divert is popping up and down with an air actuator, but it's diverting each carton over. What we do is we don't stop the run of the roller, of the MDR rollers. We keep them running, and the reason for that is we're cutting down on the cycles, you know, to extend the life of the product. So we might have, so you understand, 61 diverts, 3 high, that's 183 lanes. and they're all feeding inch and store lanes that are 160 feet long, storing orders in each lane. What's remarkable about this is that we're able to run these trains in. They all get singulated in space, on an indexing belt conveyor, and then the output from that is just one complete order going out to ship. The buffer system on this thing is just absolutely massive. There's no daylight coming through any of this. It's just an incredible density of equipment from one end to the next. These guys, this is kind of a specialty application for a snack food company, a pretty prominent one. And what this is about is effectively coming out of production. You've got each one of these is coming from a particular production lane up on the top, and then cartons are effectively indexed into this stacker portion of this. It's all MDR, top, bottom, carriage, here in a rotating turntable, and then that's fed out. Effectively, we're building a column so that the robot can pick it up and put it on a pallet building arrangement. So what this is essentially our testing of each one of those components in the field. And I was hoping that we could get that demo to show how it works, but I think I got to talk through it. So effectively, cartons come in on the top one at a time, and then the stacker indexes down so that we've got a stack of 6 cartons. It exits that column exits the stack, and then comes onto the turntable to get the labels to the correct orientation. And then is ejected out so that the robot can pick it up and then set it on a pallet board. A couple other things here that unfortunately I can't show them, kind of special. I'm kind of restricted in what I can show and what I can't show, right? But in any event, for each pallet board, there is essentially a 2 deep pallet rail, but within that pallet rail, it's driven by MDR roller. So in other words, we have the roller mounted longitudinally in that rail, and then the O-rings drive the carrying rollers. And so we get a 2 deep pickup for then an ASRS mile pickup after the robot builds that pallet. 15-inch belted zones for small parcel. So kind of another special. We did this for a major phone distributor because they needed really high throughput. Throughput was well north of 45 cases per minute. And essentially what they were doing is taking and putting phones in small FedEx boxes, putting them through a case sealer, and then out to a multi-bill sorter to be shipped. Real high rate stuff, but you can get away with it if you shorten up the zone based upon use case zone. So 24-inch zone wasn't doing the rate. We shortened it up, made it fit, works great. Card features most commonly used and applied. Standard zone accumulation. I hate to say it, but it's probably 80% of what we do. People love the fact that it's non-contact accumulation. We get so many customers that say, man, there's just no bumping, this is great. Flex zone. So many customers, at least in this country, they're not handling totes, they're handling cartons, and their businesses change. They start out with what they think is a specification. Hey, I'm going to have a 24-inch box, and it's going to be in a 30-inch zone all the time, and everything's wonderful, right? Let me see, we just picked up another product line. We acquired a company, and they've got a 29-inch box or a 32-inch box. And so now Flex Zone becomes incredibly valuable because they can't change the physical zone length without a whole lot of homework. But with Flex Zone, it works great, and it allows us to take that outlier product and have it still work within the system. It's a very valuable adjunct to the product. Just a simple ability to change the operational parameters. I don't want to overstate or understate how important this is. be able to, pull up the configure screen and say, okay, in this zone, I want to change the accel ramp or the decel ramp, or the speed, or the characteristics of how this thing's going to run. And do it in a way that makes sense. You've got the flexibility, you've got the ability to incorporate that variability, and it's just so, it's simple to valuable. You don't get it with a dip switch, necessarily. Okay, PLC to EZ24 card. A lot of folks, even our own, want to be able to direct the controls guys. They want to be able to direct.
And I ate them. And Erickson.
Yeah. They want to be able to direct the way a certain something works. And I think probably 25 to 30% of what we see, at least in the systems that we do, we end up just putting an easy 24 card and letting the PLC folks tell what to do. Makes all kinds of sense. One other thing I don't have up on the board here was a look-ahead feature. Really smart. To be able to look ahead and know what the zone is occupied and be able to slow down, it's a valuable feature, and I should have put it on here, but it's good stuff. Best practices. Georg, talked about this previously. I think we talk about, mean time to failure, and it's really about cycles, on-off cycles. And if you have the ability to really look at throughput and not how fast you're running, that's the most important thing. It's a little bit like being on the expressway, right? Everybody's bumper to bumper, and oh my God, we think we're getting someplace, and you're accelerating, you're hitting the brakes, accelerating, hitting the brakes, and your real throughput is 32 miles an hour, right? But you thought you were going faster. The same with NVR. I see this mistake over and over again, where folks set up, NVR to run at 200 feet a minute or more, only to find out that they're not really getting any better throughput. But they got a real high cycle count. They dropped that speed down to 2/3 of that number. Now everything is flowing for some reason. How did that happen? And the cycle count is now reduced, and now the roller life is extended. It makes perfect sense. Okay. Yeah, I can't say more about this. The tendency is to drive too fast. Just slow down. Really think about, from a design point of view, what is your throughput requirement? Okay. Safety. It's got a long evolution of MDR. And I think there was always the concept that, hey, MDR is safe. You can just grab the roller, right? Right. Well,
when it was 22 watt output, yes, you could.
Yeah. So we did some pretty extensive studies to debunk that theory, and it wasn't too hard to do. We effectively did a study by which we looked at the demographics and said, okay, for men and women in various age groups, left-handed and right-handed, what's their grip strength? What can they grab and effectively do to stop a roller? Okay, so with standard 3/16 O-rings and whatever, we're able to pretty much determine that anything that had a 3-stage gearbox and lots of torque couldn't stop it. I think you agree, Jimmy, Kazuya. So that leads into another discussion. Okay, really the capability of MDR is now starting to approach, the beginning edges of conventional equipment. So now when you're looking at NDR, you've got to maybe get rid of some of those old thought processes and say, okay, well, how do we protect people? The safety is number one, right? So and if you're going to apply high torque stuff or micro V, where you can really transmit a lot of torque, you really got to think about how safe do I need to be? Do I need that e-stop torque? For Daifuku, safety is their number one thing. So that's the re-emphasis for us anyway, to really look at things like, okay, I've got built-in zones. I've got a gap between two built-in zones. Carton is stopped on the downstream side. You know, what, you got the potential to bring another carton up to that. So now you've got rollers on 3-inch centers. Do I need to have a gap in between the two built-in zones? Right? Because now that's possibly a place where a person can get their hand trapped. A simple thought, but a simple fix. So it's an interesting thing. In conclusion here, you know, I'm freaked out by the amount of advancement in a relatively short amount of time. You know, what I think I see and understand is that the small group of people that we've got that are leading up each company, they're still very agile in their thinking. They're still very flexible and open to ideas and concepts, and all the improvement and feedback loop stuff, you know, continues to drive and move the ball forward. The state-of-the-art of MDR is really moving forward at a very quick pace. And I think what's stunning to a lot of people is that even 3 years ago, what we have today, or what we'll have tomorrow, is radically more advanced, more effective, more cost-effective. I don't know, Pat, do you agree?
Sure. You're the one talking, so
Okay, turn your head and say yes, okay.
Pat agrees because he knows what's coming and he's dreading it. Because he's got to document it.
I think the next statement here is probably on target. We got continuous improvement. We're providing a good testing environment to provide feedback. I'm sure all of you are doing that with Insight and Kiowa and industrial software, so that, you know, they're making those improvements going forward. You know, the product line is now getting what I would call mature, but it's taken, I don't know, 5 years to really make it.
5 or 6 years, yeah.
Yeah, but without, you know, our working together, it would have never gotten there.
Well, you summed up something earlier, Don, and I wanted to say this is about the firmware, the continual changing of firmware.
Yeah.
Was part of that feedback.
Oh, sure.
You know, it's not the fact that it wasn't working right. It was like, well, it'd be better if you did this.
Right, right.
So you're constantly upgrading.
Correct.
And we
Correct.
made our own nest is what happened.
Correct. You know, at the same time, but when the controls folks would see a change, it would be like getting a change from Microsoft.
Right.
I got another
Good luck.
update. You know, what happened here, right? Okay. So the operational bond is continually changing. And, you know, I think you know, we're moving forward with MDR. I think it's going to reach a bit of a plateau. Unless, of course, we've got some very creative people doing something else, right? And I think ultimately we've got a great team that has provided some really great results. I'm happy to be part of that. You know, I mean, we're first adapters. I mean, we're the guys that came out of the box and said, okay, we'll be on the leading edge of whatever you're coming up with. We're happy to do that. You know, I think it was a lot of discovery. I think it served us really well. And that's that, but I did want to close in saying that our MDR product line is the most profitable of all of our product lines. We've had ridiculous growth in the last 5 years, geometric growth. We're doing expansions to our roller lab because we have to, and we're finding a lot of repeat customers. So it's been a good ride. Real happy with it. We'll entertain questions, or you can throw tomatoes.
When developing your 20 or so product lines, how big of an engineering team did you have?
I had 4 people that worked full time on it for 6 months, and you know, some of the other things were more complicated. There were 2 figures, you know, a divert figure and a merge figure that gave us some problems. It took us another 2 months to nail those guys down. So, and I think I want to emphasize is it wasn't just doing 22 figures with just the ERSC card, but it was doing it with the CRSC card. It was doing it with each veto, so we did 66 figures ultimately in our history. And then DeviceNet, we just threw that in. Other questions? Well, other than the fact you got, how fabulous are you guys?
We're just wonderful. No, I want to thank Don for a very nice presentation, and truly, he summed it up very well, in the fact that they were an early adopter of our technology. And we all felt the pain, believe me. You know, we went through a lot of iterations of product improvement over the years. And a lot of driving time between here and Chicago, and from Chicago down here, and back and forth on the phone, all hours of the day and night sometimes.
Yeah. But the very, very cool thing is though, is that, you know, as a partner, they were always available to help us in every way, shape, or form. And I say that sincerely. I mean, Jimmy, I mean, you get a call from us anytime, right? And you're always there to help us. You never said, hey, I'm not available.
Except when it's windsurfing.
Yeah, there are those times. Well, there's that. The same with Kazuo or Pat or anybody. You guys have been just a delight to work with, and I'm absolutely proud and honored to be, you know, part of that. Of course, we blood a little bit, but everybody knows. Thank you so much.